All right, so we've got a file archive to download. Go ahead and get that downloaded and get it extracted. And in the meantime, we'll kind of talk about what's in that file. But first, you got to set the Wayback Machine for the 1970s. I'd be surprised if anyone here was alive in the 1970s besides me. Anyone else? Any older students here in class? No. In the 1970s, if you worked at a company that had a computer, how many computers did your company have? One. Yeah, just one. And you might have hundreds of employees that need the information on that computer to do their job. How do they get the information? They just take turns. They line up at the door. Okay, now it's my turn on the computer. Okay, now it's my turn. That's not how it happens. How did it happen? How did you get the information? You might get you might get a sales report. You need sales information to decide what you're going to do, in this coming month for whatever. How do you get the information? We're recording all this information. The business. How do you get it? How does it come to you? Yeah, it comes to you printed on, we call it green bar paper. Have you seen it? It's wide. It's like 17 inches wide. It's got holes on the side because we're running it through a printer. And it's fan folded. It's all one long thing, and you can kind of lift it up and you can kind of go through it and whatever. And that's the way these reports came. You might get, several hundreds of pages of your data every week would come. There's a guy whose job is to take the reports around. That's his whole job. He's got a cart. He's got, all these different reports. He knows where they go. He goes down, drops it off. Didn't happen in the 70s, but by the 1980s, the guy's always wearing a Walkman, right? Because he's kind of cruising through. He's listening to music while he's delivering all the paper. And so, that was the way that you got your information. Now, really starting in the 1980s, and for sure by the 1990s, we have lots of personal computers that are being used in business. In fact, what was it? What was the combination, or what was the piece of software that made businesses for the first time think, oh, that personal computer, that might be useful? Do you know what piece of software it was? No, it wasn't graphical operating systems. Okay, so Lotus. You say Lotus, it was a spreadsheet, an early spreadsheet. Yeah, it wasn't Lotus, it was a product called VisiCalc. In fact, the whole reason that Lotus got built was because VisiCalc was looking pretty successful. And so it was VisiCalc with the Apple II computer, I think, was what really got businesses thinking this could be useful. And so by the time we have Lotus on the IBM PC, yeah, it's pretty serious. But we got a problem here. These little personal computers are really powerful. When we say really powerful, at the time, they could do some powerful things, but they don't have the data that they need. Right? The data's coming on paper. How are you going to get, if you're going to do some kind of forecasting, or you're making some kind of a spreadsheet, do some kind of a forecasting, you've got all your historical trend data coming to you on paper, how are you going to get it into Excel or Lotus or VisiCalc, whatever it is? It's not Excel. Excel doesn't really come on the scene until the late 80s. You don't want to type it again. You might. You got to get that data in there. Here's the problem. These systems that are actually running the business in the 1970s, 1980s, they were never, ever designed to share data. Why would you ever share the data? You only have one computer. What are you going to do? Take it off and give it to your competitors? Well, these things didn't. There was no way to export data. They don't have. You want to get data into your personal computer? It's a floppy disk. There's no floppy disk on your mainframe. It's they're totally incompatible. And yet, the need to be able to get data from the main system onto these little independent computers was pretty substantial. So someone's going to figure it out, and they did. Someone was brilliant. Anyone know how they did it? It was a dramatic idea. It was fantastic. Now, got to understand how these printers work, right? You're printing off all this data. Today, when you think of a printer, you think about you got fonts and you got graphics and you got color. Oh no! In the 1970s, you didn't have any of that. You had characters. And so you plugged in a computer, you plugged a printer into the mainframe, and you said, "Oh, I'm just going to print to that port," and you would just send characters. Like you'd send to capital A. What, by the way, what sequence? What number do you send for capital A? At least in. Yeah, 65 is that number. It was probably different because the mainframes they didn't use ASCII, they used something called EBCDIC. It was a different coding scheme. But you'd send the number and it would go, oh, that's capital A, and then it would strike the paper, capital A. And you'd send another letter or another number for a letter and it would strike the paper. And then you'd send it a carriage return and it would move the print head back. And so it was really simple. Well, they said, if we just made a printer that when it got all these characters, instead of printing it to paper, instead it wrote it to a A floppy disk. Instead of printing onto paper, what if we printed to a floppy disk? We could plug it in, and as far as the mainframe knows, it's an ordinary printer. But when we're done printing, whoosh, we've got a floppy disk. And that will let us get the information off. Now, as it turns out, so that in the 1980s, that was everywhere. That was rampant. It's not so rampant as it is today, but it's still pretty common. What do you think? Of those systems that were running like large insurance companies in the 1970s, 1980s, what percentage of those do you think are still running those insurance companies today? Do you think it's more or less than 50%? They're still running the same software that they were running in the 1980s. You think less? I don't know. I think it's probably more. I don't know for sure, but these legacy systems, they have tremendous staying power. By the way, what do you think? How old do you think the system is here at BYU that runs your grades? That generates your transcript. We need a transcript. It goes back into the 1970s for sure. Same underlying code that we use. Yeah. Yeah. So a lot of these systems we call them legacy systems. They're mission critical. They're getting the job done. They're going to be really expensive to replace. And we're thinking, I'm not quite sure why we replace it. It's doing the job. It's doing what we need to do. And so there's quite a few of these still. And so what we're going to see today then is actually the process of taking data that we get out of these kinds of systems that comes to us in a semi-structured format. Now, what would be a structured data file? What's an example of a highly structured data file? Give me an example of a highly structured data file. Delimited, that's what I'm looking for. Like comma delimited, tab delimited. PDF probably normally, if it's just like a report or something, we call that unstructured data. So someone's writing English language here, unstructured. Well, this is kind of halfway in between. This is semi-structured, and so it's not so structured that we can say, look, every line is a record and there's a comma between every column. But there's enough structure to it that we could write a program to pull that data off, but it's just only partially structured. So that's what we're going to be working with today, semi-structured data. We'll take a look at it here in just a minute. So I thought it was really interesting today. Those legacy systems are almost uniformly written in a language called COBOL, common business-oriented language. Happened to be the lowest grade I got at BYU. In fact, I think they quit teaching it the year after I took it. I got a B- in that class. That was a sad class. But there's one program in Tulsa, University of Tulsa, the school in Oklahoma, that still teaches brand new programmers to program in COBOL, and their undergraduate students, they take jobs starting at above $100,000 a year, because these companies that run these legacy systems, everyone is either dead or dying or retired. That wrote these systems, and they need people to understand COBOL to kind of maintain them. So it's kind of an interesting little niche. So our experience then is going to be dealing with these data files. Okay, so hopefully you've downloaded these data files. And I think I have them here. Downloads. And I've extracted them. So I think the folder is called weather data. Weather data, here it is. And you should just have these. I'm not sure, this is probably from last semester or something. But I'm going to look here at this one, WSI. And I'm going to have to move my font down just a bit. This looks a little bit better. Oops. Format, font. 28, let's try 20. What does that do for us? There we go, great. So this is what the data looks like. You can tell this was formatted for a printed page. It's 80 columns wide. It's got the data kind of continues in here, but we've got these headers that will show at the top of each page, the WSI Corporation, this kind of header thing and so forth. It used to be, back in when this class was still kind of a pretty small class when we just started teaching it, I didn't give a final exam. Instead, I gave a final project. And so you'd have to go find a real business problem, and you'd have to solve it with VBA. And this was actually one of the final projects, probably around 2010 or something. This was a student, these files came from a student whose father had to deal with this data every month or so. He'd get this report, and he would have to bring it in. Guess how he was bringing the data in? By hand. Yeah, it was coming in this file like this, but he's copying it. And I'm going to copy, paste to bring it into Excel. And so his daughter said, Dad, I think I can help. I think I can help here. And so So that's what it is. So let's, somebody tell me something about this data. Suppose that your boss just gave you this and said, here's a, we need to have you, present, tell us something about this data here. Okay, so it's from Brazil. Are you from Brazil? Yeah, okay, so at least what you're seeing here, you recognize these as the names of cities in Brazil, or maybe, not quite, maybe chopped off a little bit. Okay, so this is, at least the data we're seeing here, is at least what we see on this page is from Brazil, so data. So what else can we say about this data? Tell me something. Yeah, go ahead. Okay, so there's some structure to it. Yeah, it's kind of semi-structured here, and so I've got rows and columns. That's pretty good. All right, what else? Tell me about the content. What can you figure out about the content of this data? What is it? Is it salary information? Is it sales data? Yeah, it's precipitation. And so when I look here, I'm seeing, what does it say here at the top? Yeah, it's a 24-hour precipitation tabulation. And so here, what does that number mean right there? We had 9 millimeters recorded in just January. January. Sounds so much more sexy if you say it that way. 9 millimeters in January. When? On the 8th of November, 2008. Yeah, that's what that data says. And so our goal today is to be able to write a program that will read this file, and it will take this data and put it into Excel in a way that we can use it. Let's talk about how we'd like to have that data show up. Well, I got to make a new file. Alt F N L. Ooh. New. There we go. All right. So what columns are we going to want to pull off of this for this data? What do you think? If we're going to make a column of data, what should we have? Throw one of these out to me. All right, so city, I'm going to call it station because that's the header that it has here. So I think it must be some kind of weather station in that city. And by the way, Brazil guy over there, any idea why the ones with asterisks, are they somehow fundamentally different from the others? Are these all cities? I'm not sure what the asterisk, I do not know what the asterisk and the dollar sign means. But I'm hoping that you look at that and say, they're all names of cities? Yeah, probably something that says it's a particular kind of station. Maybe it's, I don't know. Anyway, we don't know what those are. Okay, so station is there, so I'll make one called station. You can probably do this along with me. We'll want this done in here. Why don't we go ahead and do the call? I don't know what that is, but maybe that's like the number of the station or something, but we're just going to call it the call. And then what else do we need? We're going to get this information, this precipitation, need the date, and then probably just the precipitation. I think that's it. So what we're going to do is we're going to take this file and we're just going to push out a bunch of records this way. So this, this kind of comes in a little more tabular format, right? We've got multiple days showing, but I think for our data, the way we have it structured, we want to have it as just one record shows the station, the date, and the precipitation. So that's going to be our task. You ready to do it? Let's do it. So let's go ahead and come into VBA, insert a module, insert module. Oh, I better go ahead and save this. I'm going to save this file. And I'm going to save this file just so that I can, kind of put it in the same, I want it close to my data. It's my downloads folder, which is exactly where I extracted those other files. So I have a folder in my downloads folder called weather data, and I'm going to put this file not inside that, but right next to that. So it's going to be in the same place where the weather data one is stored. So wherever you put it, save the file in the same place. I'm going to call this weather winter of 19 and XLSM. Save. All right. Not sure what I just did, but it was wrong. Alt F10, Alt F11. There we go. Okay, so I've inserted a module, and let's go ahead and now ultimately what we would do is we would give the user some way to pick the directory, right? We might use the Office dialog box. Hey, choose the directory where the data is. We'd get that directory, and then we would process through all those files, and we would, kind of work them one at a time. But we've already done other examples of that, so we're going to skip that. We're just going to get to the part where we're executing one file at a time. So we're processing one file at a time. So let's go ahead and create a sub called process1. And we're going to pass to it the path of the file that we want to actually work with. We'll do that as a string. Because this code that we're going to be writing takes a parameter, we'll want some way to execute it easily. So I'll make a sub procedure here called my Acme sub runner. And we're going to call process1, and now I have to give it the path of the file that I'm trying to parse. So let me just do this workbook. I'm just going to print out the path of this workbook to kind of get me headed there, because I know they're close to each other. So that's the path to where the workbook is. And then it's in a folder called weather data. And then the file itself is called this. WSI space 2008x11.txt. So now, my process one's not doing anything, but I'm at least going to print off the path so I can see if it's working. Debug.print path. Right, so I should be able to run my Acme sub runner. Yeah, so the question is, what's this right here? That is the name of the text file. So I have, this is the full path to where that text file is located on my machine. It'll be different on yours, of course. And then I've got the name of the file there. And all I'm doing is printing that off. So when I run this right now, it should just print the name of that file. Well, of course, I don't just want to print it. I want to open that file. Now, the only way we've opened files so far has been to open workbooks. Or I think we've opened comma-separated variable files, but Excel knows how to open those up. You can just open up a CSV file, and that's OK. But now we want to open a text file. It turns out Excel doesn't do so well opening text files. It doesn't say open a text file. I think it would try to dump the text into a worksheet, but we don't want to do that. We just want to open the file and work with it directly. Well, fortunately, VBA is meant to do that. So here's what we're going to do. Instead of debug.print the path, I'm going to open the path. We'll just say open. Now, when I open a text file, there's several things I can do with it. I can take data from the text file and use it as input to my program, or I can use it as a repository to push output from my program into the text file, or I could open it to tack onto the end. The file's already there, and I don't want to replace it. That's what output would do. I just want to pump something on the end of the file. I can append it. Or there's another one called random, where I can read or write from the same file while we're working. We're going to do this for input. Now, it seems a little strange. I'm going to open the file for input. It almost sounds like I'm going to be putting stuff into the file, but no. It's from the perspective of the program. We're going to open the file to input data into the program. So open path for input. By the way, this part of the language that we're working with today it's going to feel a little bit foreign to you because it's not object-oriented. There's no objects, there's no properties, there's no methods. We're going back to before BASIC had objects and properties. This is the way we did it back in the olden days. In fact, if it was an object, we'd be able to have a reference to the object for this file, and we could just use that object to do whatever we want to it, but there's no object here, and so we have to have some way to keep track of the file we just opened. So we say as, we put a number sign, and then we give it a number. The point is that we could have 3 or 4 files. We could have as many as we want, but we'd have 3 or 4 files open at once. You know, when we're reading data from these 3 or 4 files, we're doing something with it, and we're pushing it out to another file. And so we need some way to keep separate the different files that we have open, and that's what that number does. By the way, Microsoft has since given us objects that we could use for manipulating text files in VBA. It's called the file system object, but it's built into Windows. It's not part of Excel. Built into Windows. So we have to, like we did with the database objects, we have to go get the right reference set up, and then we have to create those objects, but they're not available on Mac. But this is part of the VBA language, so this this does work on Mac, so you can open text files and work them this way on the Mac as well. Okay, now I got to do some stuff with that file while it's open, but while I'm thinking about it, I'm going to come to the bottom and I'm going to say close number 1. And we're going to get that file closed. So if I open the file, I want to make sure that I close it, and I'll do some stuff with it in between. Go ahead. So, jokes that you might have heard in second or third grade aside, that would be okay. That's fine. The number is arbitrary. The idea is that I just have to have it separate from any other file that I might have open, and because we're only going to open one file at a time here, it doesn't matter what the number is. Question? Oh, the question is, why don't I put parentheses here? The quotes are there because I have to have the quotes. It's a string literal, right? Why not parentheses? I'm not asking you. You asked the question. I'm asking someone else. Go ahead. Hold on a second. The comment is because there's only one parameter. In fact, because there's one parameter, I could get away with putting parentheses here if I wanted to. So that would work either way. But the reason, but I don't have them there. But why don't I have them there? Why is it that if there were 2 parameters, I still wouldn't use the parentheses? Go ahead. Right, I use parentheses when this thing is sending something back that I'm going to do something with. And this isn't ever going to send anything back, just a sub procedure. Yeah. And this is one of the most frustrating parts about teaching this language, is that, yeah, I can put the parentheses here if it's only one argument, but as soon as there's 2 arguments, the parentheses are going to cause it to break. And so, but the point is, we put parentheses when we're calling a function, something that's going to send a value back. This doesn't send a value back. The parentheses don't belong there. It happens that they are okay if there's only one argument. Don't do it. And so I think I've mentioned before, Microsoft has repented about that design decision. And in the current versions of Visual Basic, visualbasic.net, they just say put the parentheses everywhere. Every time you think you might put a parenthesis, that's you should put it there. Okay. So now we have it open and we have it closed. We're going to do something in the middle. Now we're going to take a look at a couple of different ways of accessing this file. So back when this kind of code was written, what do you think? Was it common for us to have files that were too big to read into memory? Yes, really, really common. Because how much memory do we have on a PC? No. So 640K was like the IBM PC when it came out with MS-DOS, 640K. And in fact, when they made 640K, right, so 0.6 of a megabyte. When they made that, the initial proposal for MS-DOS was to have 64K. And someone said, oh, we don't think 64K is enough. And so they said, oh man, all right, we're going to give you so much more than you would ever possibly use. We're going to give you 10 times that, 640K. Right? So yeah, having a file bigger than that was really common. And so we needed some way to be able to say, I'm not just going to load that whole file into memory. I want to be able to process that file a little bit at a time. And so there's a couple of approaches that we do for that. We're going to use one of them, but I'm going to show you a couple of them right here. So let me go ahead and create a variable up here called, I'm going to call it one line, even though we're going to start off with it not actually being a whole line. In one line as a string. And here I'm going to say one line equals, and there's a function called input. Input. I tell it how many characters I want. Let me bring 100 characters. And I tell it what file number, in this case, file number 2. Now, what happened to file number 1? Some student asked me, why don't I put a 2 there? And so I put a 2, and we're going to stick with it. So it's file number 2. There is no file number 1. The number is just arbitrary. Just some number. It could be, 426. That'd be all right. Does it have to be an integer? Like, could you put like 2.6? I think 2.6 would cause an error. I never tried it. Give it a shot. Let us know how it happens. Okay. All right, so I'm going to go ahead and just put a stop statement here. And I'll run my code to there. Let's take a look and see what we have in one line. O-N-E-L-I-N-E. Apparently it's more than one line. Let me ask the length of one. What do you think the length of one line is going to be? Hopefully it's exactly 100, because we said read 100 characters and put it here into one line. And in fact, I'm guessing that we've got like 20 characters here because I think that the standard was 80 characters wide. So we should have 80 on that first line, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. I guess we had not quite 80 lines because of 80 characters on that first line because it didn't go all the way to the edge. It went close to the edge. But that looks like what we have there. Okay, so if it was a small file and you could read it into memory, it was possible, but you could do it with this. But how would you know how many characters to read? And the answer is you can ask. There's a function that's a regular function part of VBA called LOF, length of file. I put what file number I'm after, and that tells me how many characters there are in the file. So now I could put that for the number of characters, and that says read the whole file in. I think because I've already read some of it, if I say to do input again, it's going to try to read past the end. So I'm going to stop. I'm going to run this code out so it closes the file. And I'll run my code again. And now let's take a look and see what the length of one line is. Yeah, 33,000 characters. And if we actually print off one line, it's going to be a lot. It's all that whole text file. Well, the immediate window only has 200 rows. And so it'll kind of scrolls off into oblivion after that, but we have read that whole file into memory. What do you think? You got like 16 gigabytes of RAM now. Do you think there could be a text file you would have to process that couldn't fit into memory? Have you ever seen a file bigger than 16 gigabytes? Well, you got a lot of stuff also happening in memory. The program's loaded in memory, the operating system's in memory. So you don't really have 16 gigabytes, but yeah, I mean, that's not uncommon. You know, in the world of big data, we could have files that are dramatically larger than that. We might have to process. In that case, we wouldn't be able to read them into memory. So let's see how we could actually go after those one line at a time. So it's a little different approach. I'm going to go ahead and comment this one out. And here's how we do it. There is a statement called line input. Again, just a part of the language. It's not an object, it's not a method, it's just part of the language. I then tell it which file number I'm trying to bring data from, and then I tell it the variable I want to put the data into. One line. By the way, what happens if you try to open file 2.1? Oh, you didn't try yet, okay. Yeah, you're not getting paid to actually do that part. You're getting paid for me to show you stuff. I get it. Oh yeah, okay. So, so now it's going to read one line. Now, if you were to look at this file, it's just a sequence of numbers. It's just, we get down to it, it's all just a bunch of ones and zeros. And so how does it even know where a line ends? Well, here's what happens. It looks at the first eight bits, and it goes the first 8 ones and zeros, and it goes, I'm going to convert that to a number between 0 and 255, and then I'm going to take that over to the lookup, to the ASCII table to figure out which character it is. And if those ones and zeros equate to 65, that's a capital A. That's a capital A. 66, it's a capital B. 67, it's a capital C. But if it gets to character number 13, that's the carriage return character. Or it's the line feed. It's one of the two. And then followed by character number 10, it goes, aha, carriage return line feed. Remember in the days of printing, what would we do? We'd send out all these characters, and we have to tell the printer, send the print head back. A carriage return, advance the paper, line feed. And so that combination is what's at what says, that's the end of a line. And so what line input does is it reads character by character until it finds character number 13 followed by character number 10. And then it says, that's the end of the line. I'm going to stop right there. And it will just bring that information back and plug it in there. So, in fact, if we were to, I think my line input still has the whole thing in it, right? Length, I haven't run that new code yet. Line input. No, it's one line, length of one line. Yeah, it's got the whole thing in it. So let's just take a peek real quick at our first character. What do you think the first character is? Looking at that text file, what do you think it is? I'm going to look at one line. I'm going to start at character number 1. I'm going to take character number 1. Doesn't look like a whole much because it's a space. You look at that file, it starts with a space. The first character is space Second character, third, fourth, fifth. The sixth character is a 4. So if I look at the fourth character, start at the, it's the sixth that I, oh yeah, the sixth character is a 4, sorry. Would help if I was at the top of the file. Here we go. Here's the top of the file. The sixth character is that W right there. The seventh character is the S. Right? If we go all the way out here, I think that's probably 80, 79. Let's go to like 75 and see if we're kind of towards the end there. 73. Okay, so that's 73. So 74. Oh, the next one is 74. So let's see what 74 is. In fact, before we do that, let's just ask for the ASCII value of that character. So capital N should be 65, 75, 85. It's about 80. 78. Okay. So capital N is character number 78. I'm interested to see what the next one is. 74. There it is, 13. Character number 13, which is either carriage return or line feed. The next character, 75, should be the 10. So that's the end of line sequence. It's just, as far as the file is concerned, it's one long stream of characters. And so when I say read line, it just reads all the characters until it finds 13, 10. It goes, aha, it's the end of the line. It doesn't return the 13 and 10 because that's just a delimiter to it. And it brings that back. So now when I run this, I'm going to go ahead and stop my code and run it again. And now I look at one line. It's that first line. There it is. What if I want to get the next line? I just call that again. So if I want to get to the second line, I'll just go back and run that second one again. F5. So now one line is that second line, whatever it is. What happened to what was in one line before? What happened to the first line of my file? Where'd it go? Yeah, poof. I read it into memory, put it that location in memory, called one line, and when I read the next line, it wrote right over the top of it. Get rid of that old one, and I've got the new one. It's still in the file. I didn't like take it out of the file. It's still in the file, but I don't have access to it anymore in my program. Question? How does it switch to the next line? What if you just want to read line 3 and you don't want to read lines 1 and 2 on the way? No can do. And the reason is that we don't know how wide the files are, or how wide the lines are. So if we knew that each line was 50 characters wide, we could jump directly to that location. It would be faster. But here, this is for like sequential reading that file. The only way we know where the line ends is to read until we find the line end sequence. So you cannot get to line 3 without reading all of line 1 and all of line 2 because it doesn't know where line 3 starts. It's got to read the whole thing to find it. Now, that's one of the things we can do with random. We can open a file with random. If we know some more about the structure, if we say, oh, we know these lines are 50 characters wide, we want to get to the 500th line, we just take 50 times 500, and we could jump right to that location. If I open this file as random, we can do stuff like that. But open it for input, it's for sequential input. Question? Oh. Okay, so the question is, shouldn't we have some kind of loop involved here? And the answer is yes. So this example is just kind of getting us going. Ultimately, you're correct. We're going to have some loops involved. Oh, how does it know I want the first and second line? And the answer is, when I say line input, it gets whatever the next line is. If it's the first time I call it, it reads that first line. And so it's read that first line. It knows where it left off. And when I say line input again, it calls the next line. It finds the next line. It just keeps going. A dozen times? Yeah. If I just copied that multiple times, it would read each line. If I was doing something with one line in between, we could see it. In this case, I'm reading the first line, throwing it away, reading the second line, and it's what's there in memory. Okay. So now that we're working with this semi-structured text, we gotta figure out some. Oh boy, if this was comma delimited, we would just say import the comma delimited file. We'd be done. But there's no standard way to look at this kind of file, right? And so we have to come up with a procedure to go after the data that we want. Now we need. And one of the things that's a little bit also problematic here is that we've got this kind of summary block first that we don't care about. We are after the actual raw precipitation numbers. So we're going to have to come down here and we're going to have to find our city name, our station name, the call number. That looks pretty good. But the next piece of information we need is the date. Control, zoom in just a bit here. So we've got to pull that date. Now, where's the date in this file? Where is the date? What's that? Well, there's a date in the header, but this isn't all for January 10th. And this is just saying this is from November 10th. So part of it, what we need is here, but the dates we're interested are down here. But that's not a date. What is that? That means November 4th of, or it's the 4th of, and the header will tell us what the month and the year is. So that's a little bit challenging because the date's not just in one place. We got to go get different parts of the date from different places. So let's start off by pulling the date, the month and the year, right from here, the second line. We've already written, we've gotten ourselves to the second line. Let's just go ahead and read in the month and the year. So at this point in our code, I'm holding in one line, I've got this line right here that's got the month and the year. Now I need an algorithm, a VBA algorithm that will go and pull in the month and year. How am I going to do it? Any thoughts? What combination of programming wizardry could we use? Go ahead. Okay, so I could, I think that would work. I'm going to start here with character number 1, and I'm going to say, is this numeric? Is this a number? It's going to say no. I'm going to keep going. Is this a number? No. Is this a number? No, 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 no. Keep going until, is this a number? Yes. Aha! I found it. Okay, that's one way that we could do it. Other thoughts? That would work just fine. It's more code than I want to write. Other thoughts? We could trim it, and that would get rid of the spaces, but still, I need some way to figure out where that date starts. Now, what no one has said so far is just go look at the 12th character, or whatever character that is there, and you think that's probably not a good idea because you're looking at this and you're going, that's June. What's going to happen when it's January? Or March? It's going to be a different number. Well, March, M-A-R-C, oh yeah, it's 5. Be a different number of characters, and so I don't think I can just jump to the same column. But what else could I do that would be a little more reliable? Go ahead. Page number. Okay, so I could, right here, like this number here. So yeah, give me some VBA. This is what I'm trying to extract. What function, what VBA function or process of steps is going to help me get there? If I look for the word page, I could look for page, but it's kind of far away from what I'm after. I think page is going to be there every time. Other thoughts? How about the dash? Okay, maybe the word to. Yeah, I could look for to, or I could look for the dash. I like the dash. I think either of those would work. I could say to, and then I know I'm pretty close. I don't quite know exactly how close I am because 10 November, these are going to sometimes be 2 digits, sometimes it's going to be 1. But if I'm looking for the dash, that dash comes right before my month. I think that's what I'm after. So let's go ahead and do that. I'm going to give myself a couple of variables here. I'm going to create a variable called Moyr, M-O-Y-R, as a string that's just going to hold the month and the year. As it turns out, it's the same month and year for every single. This whole file is only in that month and year. In fact, even if you look at the other files, you'd see that even if we had a week that was in 2 different months, like it was the 30th, the 31st, and then the 1st, 2nd, 3rd, those would come in 2 separate files. So I'd have one file that has just the end of that week, just the beginning of that week that's in the old month, and then the end of the week that's in the new month would come in a different file. So it's always limited to just 1 month and year. And I'm going to have to do something to keep track of where I found that dash. So let me dim something to represent my position, POS, as an integer. Okay, so just str. It's probably hard to see that T from all the way back there. Let me darken that T in for you, and you've got it okay. All right. So now I'm gonna ask, where's the hyphen? How do I ask it? Tell me a function that will let me ask where the hyphen is. Ah, you're thinking like Excel people. Think like VBA people. In string. Starting at the first character, looking at my one line, O-N-E line, and then looking for the hyphen. This will return 0. Whoops. This will return 0 if it doesn't find it, or it will return, actually where it found it. So now that I'm armed with where that position is, I should be able to say moyr equals, what function is going to help me? Now that I know where that hyphen is, what function will help me pull that thing out of the middle of this text? Mid. Mid, looking at one line, starting at the position, and taking NOV hyphen 08. 7 characters. Wonderful. I'm going to run my code again. And now let's take a look at what I have in moyr. Yeah, hyphen November hyphen 08. You might think we should get rid of that hyphen at the beginning, but ultimately what we're going to do is we're going to take the 4 from November 4th and we're going to put it together with November 8th, and we want that to look like a date. And so ultimately we need the hyphen there. So I'm going to leave it there because it was just kind of convenient to pick it up that way. We'll splice it back in later, but it's right there. Okay, step 1 down. I've got the month and the year. Okay, so far, kind of show me how you're feeling about parsing text. This is the process. This is how you do it. Show me your hands. I got 5s. I'm seeing 4s and 5s. Not too bad. I think I'm seeing a 3 or a 3.5. Okay, a couple of 3s. All right, and this is the process of working with semi-structured text. You're saying 5 still. You have a question? Oh yeah. So the question is, what's that 7? Where's that 7 come from? And the answer is, the position tells me, I've asked, where does my date start? It's character number 18 in this string. So when I use mid, I got to tell it where to start. So here's the first character, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So that is the 18th character. That's where we're starting. And then we're saying, take 7 characters. There's 1, 2, 3, 4, 5, 6, 7. And so that the 7 says, starting with the 18th character, pull the next 7 characters. All right. So next, we've got to figure out, so we've got that. And the good news is, our moyr, our month and year, is going to be the same for everything that we write. So we've got that part figured out. All right. Now, what's the next piece of information that we need? This first block here that has all these % of normal precipitation, we're not after that. And we might be in some other context, but we're just after the raw data. So we've got to skip by that. We've got to keep reading a line. We've got to keep calling read line or line input until we get to something else. What's the next piece of relevant data that we bump into? Okay, so you might think, I think this is like a state or something. And we could pull this in, but it would give us just a little bit more time to do that. I'm going to skip by this. We're just going to go straight to the city. But if we go to here, we've lost something valuable. We've gone too far. Yeah, this line is the next line that has data because we need to know the days. We've got the month and the year. Now we need the day. And then after that, we've just got to pick up the city, the call, and the actual data, which is going to be right in here. So now we got to do something. We have to read lines. We don't know how many lines we have to read. Wait a minute, maybe we do. Can we just read a fixed number of lines? No, because this is an arbitrary list, and those are going to be different lengths for different. So here's, in Sao Paulo, it's not nearly as many weather stations here. So we can't just read a certain number of lines. We've got to keep reading lines until something happens that we know we've found the data that we're after. So we got to find something that we can keep reading until a do loop, right? Do line input until something. And it doesn't have to be the actual line we're looking for. It could be a line before. Oh, here's a line. Now we know now we know we're only 2 more lines away. And so after we have that, we can say read 2 more lines and then we're good to go. So what is it? How are we going to find it? Any thoughts? It's kind of the creative part of doing this. I don't know. There's no rule you can apply. You just got to figure out what could it be. Go ahead. Okay, so maybe we could go until we find a line that's all equal signs. Okay, so that'd be pretty good, except we're going to find one immediately. So we could say, find this one, and it's not the first one, the second one. So we have some kind of counter. Oh, we found one. Oh, but the counter's not 2 yet, so make the counter 1. We found another one. Oh, now the counter is 2, or we increment the counter. We could do that. I think there's a simpler way. Other thoughts? Now Excel down would work in like a worksheet because there's that structure to it. But remember, this file doesn't know anything about where the different rows are. So we've got to kind of read through the whole thing. Go ahead. It's like right here. You say when we get to November. So, okay. Here's what you're saying. We know there's only 12 months that could show up here. And so we're going to read it, and we're going to ask, is the first text on this January? No. Is it February? No. Is it March, April, May, June, July? Oh, it's November. Good. So that would work as well. We could do that. I think similar to what you're saying that would be a little bit better was to say, let's have a whole list of months, but then based on what our month was, NOV, let's figure out what the real name is, and then instead of on each line checking to see if it's any one of the 12 months, we could check to see if it's November. Let's find out that it's November that we're working with first, and we could do that. That would work too. Again, more code than I want to do. We could do it. Yep. Okay, so let's have a hypothesis. Maybe the line that has the dates on it is the only line that ends with norm. Anyone here in class named Norm? You get some kind of benefits. I'm not sure what it would be, but no one named Norm. Okay. So that's the question. Let's just look ahead and see, or look, before up here. Oh, here's normal as well, but this is abbreviated more, % of normal. So yeah, I like it. So let's just keep reading one line until the last 4 characters of one line is norm. That sounds pretty easy to me. Let's do it. All right, so let's see. We've read the 2 lines. We've got our month and year. I'm going to do and loop. The last class, I put myself into an endless loop, so I'm going to make sure I put do events in here. All right. Now I'm going to do until the rightmost 4 characters of one line is equal to norm. Of course, it has to be, string comparisons are case sensitive, so it has to be uppercase. Great. Now what do I have to do inside the loop? I don't have anything changing one line yet, so this is an endless loop. So what do I do inside the loop? Yeah, read the next line. Just keep reading the next line until I've pulled in the one that says norm. So I'm just going to copy my line input again. Ooh, I like it. Even though I have my do events, I'm going to save because anytime I got loops, I'm a little worried. I'm going to save. I'm going to go ahead and come back up to my loop here and run it and see what I get. Got out of the loop. That's a good thing. Let me print off one line. Look at that. Awesome. That was only like 4 lines of code. Excellent. Excellent choice. Excellent choice, sir. Okay, so now I've got the line that has my days. Hallelujah. What's next? Unfortunately, when I write this data out, I'm going to write weather station, I'm going to write call number, date, and I'm going to put one number. And then, same weather station, same call number, same date, the next number. I'm sorry, not same date, next date. I've got 7 dates here. So all this information I need, but I've got to somehow balance that with the information that I'm trying to pull in because I've got to save this because I got to get down here before I actually have the data I'm going to write out. So I need to put the days I'm working with somewhere. So let's make a variable for them. All right, so making a variable, I'm going to make a variable called days. Dim days as, I'm going to make it a variant. You'll see why. Making this a variant is going to let us do something really slick. And I think it's the first time I've declared a variant in class. Is that true? I think so. Variant. All right. So now I've gotten out of here. So at this point, I'm kind of ready to get the days. Put some notes for myself here because this code gets kind of hard to figure out where I am. Ready to get days. All right, so I just want to pull this kind of block of days in here. Now I counted this just not long ago, and if I come in 20 characters and take the next 40 characters, I'm going to get these every single time. So great. I'm going to say days equals the mid of one line. Starting at 20, one line. Starting at 20 and taking 40. Let me go ahead and run that, and let's just see what we have in days at this point. Looks pretty good. I got my days there. Now, what I got to do next is I'm going to try to put those into an array. I want to have an array of days. The problem is, I know I mentioned it here, but it'll probably be helpful if we actually see it. Let's just take a look at one of these other files. I'll come to you in just a second. So when we look at this file, what we'll see, why is that so big? Well, let's just turn the word wrap off. Is that when we get down into here where the actual days are, I only have 3. So I want to, not only do I want to make an array to hold these values, I want it to be a different size depending on how many days of data I have here. Okay, there was a question here or a comment earlier. Ah, yes, good question. So the question is, are we going to see these numbers in the same columns each time? And you can see how we've got the double underline here, and the 4 is kind of set off to the right of that one, and the 10 is there. So yeah, absolutely. So go ahead. If the oh, you're asking where does position 20 start? Position 20 is here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So position 20 is here. So it's got plenty of room to pick up if there's an extra digit in there. So one thing I could do is, I think this is right there, that pair, that's always going to be the first. Oh no, it won't always be the first weight because it kind of shrinks into the center. It's centered if it has fewer ones. So here's what we're going to do. We have, at this point, we've got our days sitting right here. We need some way to get that into an array. What could we do to take this string and put it into an array? We could use spaces as a delimiter. And what function? Split, yeah. We could use split and we could use spaces. Now, the trouble is, I've got a bunch of spaces, and every time I have a space, it's going to be the delimiter. And if there's nothing between two spaces, it's still going to give me 2. It's still going to act like a delimiter. So I'm going to have a lot more than 7 here. So I got to do something to get rid of all those extra spaces. Okay, so trim. In VBA, there's a trim function, but all it does is take off leading and trailing spaces. But the trim function in Excel does something more. What does it do? The middle ones get squished down to a single space. It's exactly what we're looking for. Oh, somebody made it for us. If only there was a way for us to call an Excel function from inside of VBA. Worksheet function. Let's go ahead and do it. In fact, I could wrap it right around this. I could just say worksheet function. Oops, worksheet function dot trim. So we're going to get the mid of one line, we'll get that block off of one line, then we're going to trim it, and then we should have something that looks a lot better. Let's look at days. Sure enough, that did exactly what we're after. There's no leading, there's no trailing, space. Yep, there's nothing at the end of that. Everything now just right below it. Ah, who invented this? That's wonderful. So now I'm ready to split that into an array. And I could actually do that on this one line, but I'm going to do it in a separate line. Days equals split of days. This is why we made days a variant. Because now I'm about to treat days like an array. And that's what variant does. You treat it like an array, it'll handle it like an array. The question is, will it be a problem if it's number 10? Now, split uses a delimiter, and I did not tell it the delimiter. The default is a space. And so I can go ahead and write that in. It works exactly the same. And so this is saying, cut this string of days into an array based on the presence of a space. And so the fact that I've got 2 characters for number 10 is not a problem. It's because it's not going by position. It's just finding where all the spaces are and saying everything before the first space is one, now before the second space is another one, and so forth. And if you don't tell it what the delimiter is, it assumes space. The default delimiter is space. Great. So at this point, I have an array. I'm going to go ahead and run that line. And I think now I have an array. So if I say days, it'll say you can't just print that because it's more complex now. But if I ask for days sub 0, it should give me the 4, the first element of the array. If I ask for days sub 6, it should be the last one. So we've got an array now that holds the days. Fantastic. All right, so now from here, how are we going to get to the next data? How are we going to know when we've made it to the next data? Any thoughts? This one we found by the last 4 characters were norm. Okay, so you might say we're looking for 3 asterisks, and that would get us here. That would find this, but we still got some more to go. Trouble is, the only thing we have here is data. We might be able to look until we find a $sign, but remember, some of these start with an asterisk, and we don't really know what that means. It's possible that we'll get to one where the asterisk is the first thing. Oh. So I don't think looking for anything about that line is going to do it for us. Any other thoughts? You know what? Maybe it's just 5 lines down. Well, let's see. I've got this one. If I say read, if I do read 1, 2, 3, 4, 5. Yeah. If I do just read 5 more times, I think I'll get the right one. And I think let's just take a little peek down. It looks like they've all got that block with the asterisk in it. And so I think we're okay to do that. Yeah, I like it. So let's just read 5 more times. So for that, I'm probably going to want to do that as a for loop. So I'll need a control variable for my for loop. So I'm back to my variables, dim x as an integer. Now I'm going to say, what am I going to say? For x equals 1 to 5. Next, I'm just going to say line input. If I've done that right, at this point, I should have the Januaria data. Oh, I'm sorry, Januaria data. So let's take a look and see what we have in one line. Yep, perfect. And it looks like that will work, every time to get me to the data that I'm after. Question? Oh, yeah. So it's a little harder here, but what you're saying is maybe you could just look until you find a blank line, or carriage return followed by another carriage return. It's a little tougher here because we're using there's 2 spots that have that, but still we're using the carriage return to get the line, and so we can't look for character 13, character 10, character 13, character 10, because our approach is to say just get the line, and so we don't really even see the carriage returns at all. But we could, say go until we get a blank line. That's what we would get, and then we know we have to kind of go a little bit more after that. But I think here we're safe just to count down 5 rows. Okay, now we're ready. Right, let me go up to where we're supposed to be here. Right, we're now on the data. So I think we're almost ready to write the first line. We now can pull off the station and the call, but we have a similar problem that we had with days, and that is we've got to take all of these numbers and we've got to write them now onto 7 different lines. So before we start working with the station and the call number, let's go ahead and pull our data in, and the good news is it's going to be just like we did it with days. It's going to be exactly the same. They're even in the same columns, right? It's separated by spaces. Even when we have trace showing in here, that's still going to be okay. And so I'm going to cheat. I'm not even going to think too hard about this. I'm going to come up here to where I declare days as a variant, and I'm going to make another one called data as a variant. I'm going to copy my block that got my days set up. I'm going to paste it right in here. And I'm just going to change wherever I had days and make it say data. Now I gave it a little bit of thought to think this might work. And having just done this only an hour ago, I'm pretty sure it's still going to work. Let's just go ahead and run this and see what it produces. I should now be able to look at, let's see, what am I expecting to see? Well, a bunch of zeros. So my number 0 slot should be a 0. 0, 1, 2, 3, 4. And my 4 slot should be a 9. Let's just check. Data sub 0 should be 0. Data sub 4 should be 9. Great, we're feeling pretty good. And I think the last one was an 8. That should be data sub 6. That's an 8. So yeah, we now have a parallel set of arrays. We've got a days array with the day of the date, and then we've got a data array that actually has the precipitation. Oh, we are humming. Oh, we have to be humming because we're almost done. Okay. So I think we're ready to write the data out. So now we've got data for x equals 0 to the upper boundary of data. And we can do data or days. They're the same, so they will be the same size. Next. So now we've got 7 days of data. We've got to write out 7 rows. So, we got to keep track of what row we're on. Okay, one more thing to go. Another variable. Let's dim R as a long, be a row that we're working with. I'm going to initialize R to be 2. We're going to start writing it at row 2. Now I think we're ready to write that row out. All right. So we're on sheet 1. So I'm just going to, it's not the best name to leave in our code, but we don't have much time, so I'm going to go ahead and do it. Sheet 1 dot cells. Row number R, column number 1 dot value is equal to, we need to now read off of our one line. We've got to read January. So I think what we can do is we can start at character number 2 and take 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There will be at least a blank column, one blank cell here. So I'm going to start at number 2 and take 11. So that should be it. I'm going to look at, do the mid, one line, starting at 2, taking 11. And I think I'm going to go ahead and trim that as well, because I will have pulled on some trailing spaces for most of these. Now in column 2, we're going to start right here. These are always 5 characters wide. So I'm going to start at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I'm going to start at 14 and take 5 characters. And truth is, I won't really have to trim this one, but code's already there. We'll be okay. So I'm putting in the station. I'm putting in the call. I'm now ready to write in the date. So my next My next line, column 3, is going to be my days sub x, whichever iteration I am through the loop, concatenated with my mow year. That should put the right date in. Only one more to go. Column 4 just has to be my actual data for the iteration that we're on. Now, I'm relying on R having its value, and I initialize R way up above, and so I'm going to run this out and then run it again. And let's see what I've got. Oh, so I only have one. Why do I only have one row for January? Yeah, I never told R to go anywhere else. So we've got increment R equals R plus 1. I'll run this out, run it again. And now we've got those, we've got all those 7 days of data for January, and we've got them written into our table. Folks, we've got 3 minutes to go. We've only gotten the first one. But the good news is, that's it. Everything else is just more of the same. We just got to figure out where to put the loops in. So we need some way. Let's see, where are we? Oh, we've got to go. Oh, this is pretty easy. All right, so now at this point, we just need to keep going. Let's see, next. Oh, that gives me one line. I have to do this until something happens. So let me come right here. I've got to do this multiple, because I've just gotten January. I've got to keep going. How do I know when I'm out of my data? I got to keep going until I hit a blank line. Because I'm going to hit that blank line right there that says you're done with the data. No problem. So around this for loop, I'm going to wrap a do loop. Let me go ahead and tab it in. Do and loop until one line is equal to a 0-length string. And I better be reading another line in here. So let's get another line input. Oh, the question is, there might be a space in there. So should I trim it? And the answer is you could do that, but I know there's no spaces there. Okay, so now I'm going to go ahead and I'm going to come just do this again. I think it's going to give me January again, but that's okay. Now that should have given me a bunch more data. Yeah, so now I've got all the rest of these in here. So now I just have to do this over and over again. I just got to figure out how to find the next norm. I'm already looking for norms, so let's just do this. Let's just put another loop in right here. So a loop that's going to end there, and we're going to start just before, right here, where we're looking for norm. Do. And so now we get there, we'll come back here, we'll look for the next norm. And then we'll do the same thing. Then we'll look for the next norm. Trouble is, when we get to the very end of the file, we finished the last block. If we start looking for norm and there's not norm there anymore, what's going to happen? We're going to get to the end of the file. That's going to be a problem. And that's going to happen right here where we're doing the one line looking for norm. So after I do this, I'm going to say if EOF2. EOF is a flag that gets set just like in the database world. When we get to the end of the table, here when we get to the end of the file. If EOF, then exit sub. If we hit the end of the file where we're looking for norm, we are done. Get us out of here. Oh, that's it, folks. It's 4:45. You didn't think I could do it, but we just did. I'm going to run this whole thing again. And how many do we have? Control down arrow. 904 data records. We've successfully imported this file. All right. Excellent work. Thanks for coming today. Class dismissed.